International Space Station ISS, a mission weighing over 420 tons, is orbiting Earth at nearly 28,000 kilometers per hour, carrying astronauts, laboratories, and cutting-edge technology. How does it generate power? Producing oxygen and stay in space. In the next few minutes, you will discover the amazing engineering behind the International Space Station. The International Space Station ISS is the largest human-made laboratory in space and one of the greatest engineering achievements in the history. It is a joint project of NASA, United States, Roscosmos of Russia, ESA, European Space Agency, JAXA of Japan, and CSA of Canada. Construction of the ISS began in 1998, and astronauts have continuously lived and worked aboard the station since November 2000. The station orbits Earth at an average altitude of approximately 400 kilometers and travels at an astonishing speed of nearly 28,000 kilometers per hour. At this speed, the International Space Station ISS completes one orbit around the Earth every 90 minutes, allowing astronauts to witness about 16 sunrises and 16 sunsets every day. Although Earth's gravity continuously pulls the ISS downward, it does not fall because its tremendous forward velocity creates a continuous free fall around the planet. However, the thin atmosphere at this altitude gradually slows the station, so visiting spacecraft periodically perform reboost maneuvers using their engines to raise the orbit and maintaining the correct altitude. The International Space Station measures about 109 meters in length, roughly equal to the size of a football field, and has a mass of approximately 420 tons. It consists of several interconnected modules, each designed for a specific purpose such as scientific research, crew living quarters, storage, airlocks, and docking ports. The station can comfortably support 7 astronauts for long duration missions. Living in microgravity presents unique challenges, so astronauts exercise for about 2 hours every day using treadmills, stationary bicycles, and resistance exercise machines to prevent muscle and bone loss. Sleeping cabins, a kitchen, hygiene facilities, and communication systems make the International Space Station a fully functional home in space. One of the most important systems about the ISS is its electrical power system. The station is powered by 8 massive solar array wings. Each contains thousands of solar cells that convert sunlight directly into electricity. Together, these solar arrays generate approximately 75 to 120 kilowatts of electrical power, enough to operate scientific equipments, computers, communication systems, lighting, pumps, and life support equipment. Because the International Space Station spends about 45 minutes over every orbit in Earth's shadow, the station cannot generate solar power continuously. To overcome this, Excess electricity produced during daylight is stored in advanced lithium-ion batteries which supply power during orbital night. Sophisticated power management systems regulate the voltage and distribute electricity safely throughout the station. The ISS also contains an advanced environmental control and life support system that provides astronauts with an Earth-like atmosphere. Oxygen is produced through electrolysis, a process that splits water into hydrogen and oxygen using electricity. The oxygen is released into the cabin for breathing, while the hydrogen is either vented into space or combined with carbon dioxide in another process to recover additional water. Carbon dioxide exhaled by astronauts is continuously removed using specialized filtration systems. Water is an externally valuable resource in space, so the ISS uses one of the world's most advanced recycling systems. Moisture from the air, sweat, shower water, and even astronauts' urine is collected, purified, filtered, and disinfected along nearly 90% of the water to the reused. This recycling technology greatly reduces the amount of water that must be transported from Earth and will be essential for future missions to the Moon and Mars. Maintaining a comfortable temperature in space is another major engineering challenge. While one side of the International Space Station ISS may be exposed to temperatures exceeding 120 degrees centigrade, the shaded side can experience temperatures below minus 150 degrees centigrade. To maintain a stable internal temperature of around 22 degrees centigrade, the International Space Station ISS uses cooling loops filled with the liquid coolant that absorb heat from onboard equipment. The collected heat is transferred to large external radiators which release it into space through thermal radiation. Without this thermal control system, electronic equipment would quickly overheat or freeze. Communication is another vital part of ISS operations. The station uses high-frequency radio systems and the tracking and data relay satellite network to maintain nearly continuous communication with mission control centers on Earth. These communication systems enable astronauts to conduct live video conferences, transmit scientific data, receive operational instructions, and communication with family members. The ISS is also equipped with several docking ports where spacecraft such as SpaceX Dragon, Russian Soyuz, and cargo vehicles dock automatically to deliver astronauts food, water, fuel, scientific equipments, and replacement parts. A unique feature of the ISS is Canadarm2, a highly advanced robotic arm developed by Canada. This robotic system measures approximately 17.6 meters in length and is capable of moving heavy cargo, assisting with spacecraft docking, relocating equipment, and supporting astronauts during spacewalks. Unlike industrial robotic arms fixed to one location, Canadarm2 can move around the exterior of the station by attaching itself to different power and data fixtures, giving it remarkable flexibility for maintenance and construction tasks. The primary purpose of the ISS is scientific research in the microgravity environment where objects experience continuous free fall and appear almost weightless. Scientists conduct experiments in medicine, biology, physics, chemistry, material science, robotics, agriculture, and Earth observation. Researchers study how the human body changes during long duration space flight, including muscle loss, bone density reduction, immune system changes, and cardiovascular adaptations. These studies help doctors improve health care on Earth while also preparing astronauts for future deep space missions. Experiments on crystal growth, fluid behavior, combustion, and advanced materials provide valuable knowledge that cannot be obtained under Earth's gravity. The ISS also carries high-resolution cameras and sensors that monitor climate change, forest fires, floods, glaciers, pollution, and agricultural conditions around the world. The International Space Station represents one of humanity's greatest examples of international cooperation and technological achievement. Engineers from different countries have successfully built and operated a permanently inhabited laboratory in one of the harshest environments imaginable. The technologies developed for the ISS, including advanced life support systems, robotics power generation, water recycling, and autonomous docking, are laying the foundation for future space stations and long duration missions to the moon under the Artemis program and eventually to Mars. More than just a laboratory, the ISS is a symbol of peaceful collaboration, scientific discovery, and humanity's determination to explore beyond Earth, making it one of the most important space missions ever undertaken. Space exploration is shaping the future of mankind, and the International Space Station is at the heart of that journey. If you found this video informative, don't forget to like, comment, and subscribe the channel. Turn on the notification bell so you never miss our latest technology videos. See you in the next episode.